Okay, so here we are in Unity. Let's go through the process again. I'm going to duplicate our previous shader, and we're going to call this one here 7 underscore normal map. Once again, duplicate these shaders here, rename them 7 underscore normal map, 7 underscore normal map. Okay, great. So I'm just going to open this up. It's all fire open here. I'm just going to close these other ones because we don't need them. And let's go through the process of updating the shader. So I'm going to rename it to normal map. I'm going to scroll down and I'm going to delete the second pass. We'll get back to that in a moment, but for now we'll just work with one pass as it's considerably easier. Alright, for base, exclude render splash, that's fine. Okay, so what we want to do is we want to add in a button map. So if we just copy this line here, this main text, and I'm just going to right in here, normal texture, and make sure that the default value is bump. What this will do is if I just come through and reload this and make sure we select it, you see that we now have a slot for a normal texture, which we can go in and slot in a normal map. Okay, now you notice that it's both overriding each one. Now the reason for this is because we haven't renamed it here. So I'm going to call this one here button map. Alright, there we go, and now we can go ahead and drag those maps in. Now it's not going to do anything at the moment, because what we need to do is further use it in our shader. Let's start by copying these, and we're going to have our button map and our button map ST. So the ST once again will just contain our offsets and parameters. So I don't think I demonstrated this earlier, but this is effectively this line here. So we can do things like change our tiling in X to 2, and it will work. We can do something like 20 to be ridiculous, or 1 and 10. But yeah, it's just those controls just to help work with it. Now if you want your these two to always line up, you can actually link these values together using JavaScript, or you can just use the settings from one and the other. Alright, so that's that one there. Let's take a look at the structs. So the only one we need now is we need the tangent. So let's come in here and go float for tangent. And this has a semantic tangent. Fair enough. And coming down here we have, I'm just going to call this one here normal world. So we're going to have a few of these. Let's just go paste 1, 2, 3. And we're going to have normal world, tangent world, and binormal world. This will be text coord 2, 3, and 4. So we're getting a few text coordinates in here. Remember, when we get too many, we will have to go up and upgrade our shader. So at the end of this, we might have to upgrade this to shader model 3. So don't worry about that, we'll deal with that in a moment. Okay, so with our semantics sorted, we need to change our vertex function. Come up to the top and I'm going to copy this line. I'm going to cut this line. For our normal direction, I'm going to make sure we call this normal world. And we need to also have o.tangent world and o.binormal world. Okay, so for the tangent world, we are going to want to normalize. We want to normalize all of these. Tangent world. Alright, so how do we calculate the tangent world? We're going to be multiplying the object world by v.tangent. So this is all fine and dandy, except we're going to be writing to a float 3. This is now currently a float 4. And we are missing a bracket by the looks of it. Alright, so what do we need to do for this? We'll just come in here and after the model, go .xyz. So it's a little simpler than the line that I showed you before. The line before was something like normalize mul float 4 normal comma 0 or tangent comma 0 or something like that. Using those float 3s and float 4s, you'll see them a lot in my shaders. It is simply how I work when I write CG effects and things like that, when it's a little more particular than Unity is. So you can do it either way. I'll leave this as the simpler method for now. Alright, so this next one we're going to be normalizing, and we're going to use a cross product this time. Remember, this one here calculates the tangent to 2 vectors, and we're going to be using a o.normal world and o.tangent world. Okay, so this one here is going to be a float 3, which is fine. I'm going to multiply this by v.tangent.w, which will just correct the length for us. Okay, so we have our normal, our tangent, and our binormal. let's move on to our fragment function. Okay, so there is a bit more code to add in the fragment function, but we'll see what we can do. So I'm going to first take our texture maps above the lighting so that we can keep them together. And we'll hit create a new one called text in. Make sure we have our bump map. And bump map there, and alright, so let's add our texture map in. Now what we need to do is use the unpack normal function. Now this function here is one that's actually included in Unity. I was going to do a CG include like everyone else and just add it and tell you, unpack normal of this, and Unity will deal with it for you. However, this is not efficient. It creates a lot more code and it's just not very nice. So what we're going to do is do this manually. So we're going to have float3 local chords equals, this one here we're going to go float3 2 times textn.ag minus float2, and this one here is going to be a 1.0, comma 1.0. And of course, because we put this in a float3, we're going to want to have a comma and 0.0. That's just because we're having a temporary third vector, because we're going to calculate that one in a moment. Alright, so the reason we have minus float2, 1 and 1 instead of just going minus 1 is that using DirectX 11 it can have a little bit of a little fit, and it will say no, you have to have this as a specific number when using subtraction, and it's just kind of how it works. It's a little irritating, but there you go. Just be aware of that. The float2 there is just so that we have two values with the same. Now to calculate the local chords .z, this one here we are going to use minus 0.5 times the dot product of local chords. And so it might seem a little weird having dot product of local chords and local chords. Another thing about it, it's very similar to 1 because they're always going to be facing the same direction. So I'm not quite sure why this is in the documentation like this, but it is. The alternative is to have one like that. And this one here gives you very similar value. It does actually make a very slight difference. It's not much of a difference, but a very slight difference. Another option is what we can do. So I'm just going to add in another value here. I'm going to call this one here, just to show you, because this one's actually pretty cool. Bump depth is going to be a range of, let's go -1 to 1. Or let's go to 2.0, -2.0, with a default value of 1. Alright, and from float this will be bump depth and bump depth. So this is another option you can do, and then you can control how much of your bump shows through. So it's up to you whether you want to go the official way. This is how I like to do my bump maps, just using a variable or just set it to 1 by default. It's entirely up to you, so I'll leave you with both options. Okay, so what we're going to do next is we need to create our matrix. So let's go normal transpose matrix, float 3 by 3, local to world transpose. So we're just converting our normals from normal to our world space, and then we're storing them in this matrix. Float 3 by 3, and I'm just going to split this onto separate lines. What we're going to do is go I dot tangent world, and yes, the order of these does matter. I dot binormal world, I dot normal world. So that's a matrix, and then what we need to do is we need to calculate normal direction. So I can actually remove this one up here. So we're going to do it down here now. This is why we put all those textures above the lighting. We're just going to go float 3 normal direction equals normalize mul, and we're going to multiply the local chords by the local to world transpose, and we are done. So we've got our new normal direction, and let's just fire this up in Unity. Alright, so we have a new option there for bump depth, and everything seems to be working. So let's try it out. So you can kind of see those normals working. So this probably isn't the best normal map to use, but I can probably throw in some other ones, like let's go grab the textures here. So I, for example, did robot body and robot body normals. You can see how we can adjust how bumpy these are. So as we get closer to 0, they get more bumpy. As we get further away from 0, they get less bumpy. Alright, so let's just go back and throw the correct textures back on this. And that there is normal maps. Alright, so you can see that this light isn't, lighting at the moment. We might as well go ahead and edit this shader to work with multiple lights. Why not? I mean, it's nice and easy, isn't it? Alright, paste that in. This is the second pass, so what we're going to do is go forward, add, and let's go under here, blend 1, 1. And remember, we need to leave the we need to leave out the texture and our ambient lighting. We'll keep everything else. We can also take out our texture calculation there because we don't need it. And let's go back to Unity. Cool, alright, so now that's working with multiple lights as well. Okay, so we've done a lot so far. We've worked out different sets of lighting, we've worked out how to add on textures, add in normal maps. There's only one thing left to do. What we're going to do now is we are going to go ahead and add in some additional maps. And this is going to be in the next video.